Okay, let's do quiz 5.1. Just grinding out some basic antiderivatives, most power rules. We only have a couple at this stage. Power rules, the exponential, the logarithms, or, well, the integral of 1 over x, which is a logarithm. So keep those in mind, and that's all we got to work with for now. So all of these problems can be done via those methods. 5.2, we're going to have some more methods that'll give us more versatility. But for now, when you see something ugly like this, it's all just powers of x, except that you have a polynomial over a polynomial. And you can't really work with that. You can't just take the antiderivative of the top and the antiderivative of the x cubed on the bottom and put one over the other. That's not allowed, it's not a rule. But what you can do, for now, when I give you a problem like this, it has to have a monomial on the bottom, meaning just a single power of x. So that you are able to reduce it by splitting it up. Later on, I can give you problems that have like an x plus 1 or an expression on the bottom, multiple terms on the bottom, and there's techniques to handle that, but that's later on. So for now, this is the only approach that we have available, and it's fine. It'll work nicely. I held off on one thing. What did I do? Oh, I wanted to mention, and I did it in the notes before. You have to be able to interpret x times x square root of x as a power. That is x to the 3/2, specifically because that right there is x to the 1 times x to the 1/2, and when you combine them into a single power of x, it's going to be 3/2 power. Can you see that? It's a new pen. Okay, so that's how I'm getting the 3/2 here, even though it looks messy. Okay, if you're still not going to do top and bottom separately, you're still going to reduce each one. So this first term is just 2x squared. This second term is going to be, oh my god, 3/2 minus 3. Why did I make it so hard for myself? It's going to be negative 3/2. Okay, makes sense. In retrospect. 1 over x squared, which I should, and I also forgot the x, what am I doing? I should actually rewrite that as it's 1 over x squared, but I'm not going to do the power on the x squared. I'm going to rewrite as x to the -2, so I should do that ahead of time. So 1 minus 3 is a -2 power, and that last one is just -3 power, so that I get it in the form of just powers of x. All on top, nothing on the bottom, and just dealing with the negative powers in the same way using the power rule. So now it's a power rule. All of this is just rewriting the integral. So at no point have I dropped the integration symbol, so that it reminds me that I still have to actually do the actual antiderivative. So I'm ready to go. Now I'm going to drop that notation because I'm ready to actually take my antiderivative. It's going to be 2, and I'm going to bump up the power. X to the 3rd over 3. I'll bring out each coefficient separately, and I'll clean it up afterwards. So I'll bring in the -6, and I'm going to bump that up power by 1, -3/2 plus 1. So work that on the side if you have to. That's going to be 2 over 2. That's going to be -1/2. And I'll be dividing by that -1/2. The negative is part of it that I have to divide by. Add 1 to that, that's not -3, it's going to be -2 plus a positive 1 is -1, divide by that -1. And last one, add 1 to that, it's going to be -2, I'm going to divide by -2. And don't forget your plus c, that comes into play once you've taken the antiderivative. The antiderivative has an arbitrary constant, so when we take the antiderivative, that's when we put the plus c and drop the integration notation. Alright, final answer, if you want to clean it up, you definitely do. 2/3 x cubed, it's fine if you write it as 2x cubed over 3, that's equivalent. But definitely there's other things we want to clean up. But either one of those is good for your first term. I'll leave it as a coefficient times the power of x. Like that form, but it doesn't matter. This one I'm going to do a lot of mental math, and this one it's going to be negatives canceling. I'm going to do a reciprocal on that too. It's going to be plus 12. x to the negative 1/2. And if I want to rewrite that, I could rewrite it as 12 over the square root of x. I do not have to. It's fine with a negative power unless they, for some reason, don't want it. So those are some optional ways of writing it in a different form. Negative's going to cancel. I'll get that, which I can rewrite as 1 over x. That does not flip. It's not a fraction. It's going to just negative 2. So it's going to cancel the negatives, but I'll still have 3/2 x to the negative 2. Oops, where did I write it? Which, if you put it together as a single fractional expression, it'll be x squared on the bottom going with the 2. And don't forget the plus c. So this is good where I just wrote them as powers of x, simplified the coefficients. This one is also good where I try to rewrite it in a more traditional notation. Either one is good for that, just making sure you can do your power rule. And it's prone to errors with minus signs and flipping things and so many fractions. So just be careful about that, but the main thing is make sure you understand how to break this down, like the approach to take, because it looks ugly at first and some people get stuck in how am I going to deal with a polynomial over polynomial, but a lot of times you can simplify it and break it down into separate terms, so that's what you want to do in that situation. Alright, it didn't leave me a lot of space for a second problem, but I'm going to do it anyway because this one's pretty short. Just reminding you of the exponential, since the derivative of e to the x is e to the x, that means the antiderivative of e to the x is also e to the x. Antiderivative just goes backwards, so it takes that to that. So that's it. We're just going to keep that in mind. And deal with the negative 7 as a coefficient, bringing it down, and the constant. We do have to take the antiderivative of that. Don't forget that. That's why I threw it in this one. Okay, so that's a constant rule, and the constant rule says the antiderivative of some constant is just that constant as a coefficient times x and plus c, obviously. So if you're integrating 2, just a constant 2, your antiderivative is 2x plus c. If you're doing the antiderivative of 3, it's just 3x plus c. And if you're doing the antiderivative of 1, it is just x plus the c. So that's what we're doing. The antiderivative of that 1 is x. The plus c I'll add on after I'm finished because I have another term. And as we just discussed, the e to the x, the antiderivative is just e to the x. That negative 7 is a coefficient that comes down, just a multiple, and plus c. Okay, so that one was pretty quick. Just making a little bit weird things like the 1, make sure you know how to handle that, but once you get some practice, that should be pretty quick. And then just bringing down the negative 7 and taking the antiderivative of e to the x, which happens to be e to the x. Yeah, I can fit it over here. This is also not much work to be done, but making sure we know how to handle it. How we handle this is very similar to what we did over there. Again, you can't just take the antiderivative of the top and the antiderivative of the bottom. You need to break it down knowing that the denominator is a single term. You can, therefore, break it up into 2 separate terms, each over its own denominator. Simplify each. And then just do the antiderivative of both of those separately. And initially, I threw this one in because initially it looks like very similar to that, but less terms, where you're going to do the power on everything. You are not going to do the power on everything. I mean, you can try. This one, definitely the power rule. It's x to the 1. So we're going to bump up the power to 2, divided by 2. I've pre-simplified it as 1/2 x squared. And then this one, if you try to do the power rule, it's going to be x to the, you add 1 to that, you get 0 over 0, and that's not a thing. And when you try to do that and it's not working out, it's because the antiderivative, actually, if I anticipate I'm going to be dealing with that, I should actually think of it as 5 times 1 over x, because the antiderivative of 1 over x is the natural logarithm of x. With the absolute value or not, again, I don't care, but just make sure you follow your professor's instructions if they are particular about that. We're not worried about that right now. But anyway, the main thing is you recognize the 1 over x has a completely different antiderivative from all of these other powers of x. It is the natural logarithm of x. So the 5 comes down, the antiderivative of the 1 over x is ln of x, or ln of absolute value of x plus c. So just be on the lookout for those, especially now because it's part of the chapter, part of this section. Okay. Number 4. Just a weird radical that you have to interpret as a power. We did have the square root of x that popped up here. This one's a cube root of x squared, but that can be written as a power. Oh, and also they give you a different variable. Nothing, we didn't actually do one on the notes, but I just want to make sure that you can have different variables. Whatever the variable of your integrand is, a function you're trying to integrate, you're integrating with respect to that variable, so it should have the d of that variable instead of dx. Apart from that, it's the 2/3 power for the cube root is 1/3, and then the square ends up on top. So it's 2/3 power. That's just rewriting it, so I still have my integration notation, and now I'm ready to actually do my power rule. Add 1 to that, it's going to be 5/3? 5/3. Over 5/3 plus c. You don't want a fraction within a fraction, so you don't usually want a fraction in your denominator, so wrong number. 3/5 t to the 5/3 plus c is your antiderivative there. If you wanted to rewrite it as a radical, the 3 in the bottom makes it a cube root. The 5 on the top makes it a 5th power. Cube root of t to the 5th would be the way to write it as a radical, just as a review, but for the purpose of this, either one is good. Right. Number 5. It didn't come up, but I did want to make sure that you can handle these situations where they throw an integrand at you that has constants that aren't specified. Ax plus b dx, where a and b are just real numbers or constants. And it's possible they want you to integrate something with respect to a or with respect to b. If they're variables, they're not, they're constants. And also you know you're not doing that because it says right here. So you are going to be looking, if you ever have to do multivariable calculus and you have x's and y's, you need to look closely at that to know that you're integrating with respect to x. And so you're going to do the power rule on x, treating a and b, or in that other case, any other variable as constants. X is the only variable when we're integrating with respect to x. So we're doing what we did before. We just have to bring this a and b down, and our answer will have a and b in it. So power rule, nothing different about that. It's going to be x squared over 2, and I'm just going to bring that constant down. That's a constant. We just talked about that. The antiderivative of k is k to the x, so that's going to be b to the x, and I'll have the plus c. Final answer, you can write as a over 2, or 1/2 a is fine. Bx plus the arbitrary constant c, and that's your antiderivative. It's a quadratic with a and b being just arbitrary real, not arbitrary, but real numbers, constants. C is the arbitrary constant of integration, and that's what your antiderivative will look like. Last one, I think I need space because, no, I can fit it. They have a binomial cubed, and you cannot just do the antiderivative on that 3 and bump it up 1 and divide by 3, because you don't just have x to that power, you have a function of x within there. There's a way to treat it as just a simple power rule on the 3, but that's requiring what's called substitution in the next section, which I'm going to do right after this. But for the purposes of what we can do, which is just the power rule, we need it to expand it and make it like that first problem where you just have a bunch of powers. So you got to FOIL out. Make sure you don't just cube. It's not x cubed plus 1 cubed. Nope, that's not what it is. It is x plus 1 times x plus 1 times x plus 1, and you got to FOIL it out. I'm not going to waste our time foiling it out on the board, but I know what it is already, so I'm going to go skip to that. Okay. Again, note that make sure you're distinguishing between rewriting the integrand and actually taking the antiderivative of it. And what helps is to keep the integration notation. You're supposed to keep the integration notation until you're ready to take the antiderivative. We are not. I just expand it. So that's, again, just rewriting the integrand in a form that I can work with. Integration sign still applies. I'm now going to take my antiderivative. And so I'll just power rules. Bump that up to 4 divided by 4. Bump that up to 3 divided by 3. Bring that coefficient down. Bump that up to 2 divided by 2, and then that's a constant, so it becomes that constant 1 times x. Cleaning it up. To get our final answer, and we are done. That's it, just some practice with the power rule. It's going to come up a lot, but in the context or within other techniques that we have to learn in the next section. All right.